Okay, lots and lots of examples. This is the best way to learn this, is just keep doing it and doing it. All right, so we're going to establish an identity again. We have our left-hand side and we want to make it match our right-hand side. Or vice versa. Take our right-hand side and make it match this. In this case, we're going to work with our left side just to get some practice. This is already in terms of sine and cosine, so simplifying this, we might not have quite as many tools. But you could do it either way. So let's start with our left-hand side. And first of all, let's rewrite these two in terms of sine and cosine. So how can I rewrite cosecant theta? 1 over the sine of theta. Good. 1 over the sine of theta. And how can I rewrite cotangent theta? Cosine of theta. Good. Over sine of theta. Okay. The next thing I want to do is, since these are both over the sine of theta, it's a common denominator, I can rewrite that as one term. So I could just say 1 minus cosine theta over sine of theta. Now, why do you think I would want to do that? Possibly. Because look at my right-hand side. It's written as one term in that sense. So I didn't necessarily have to do it there, but I just decided to. Alright, so the next thing we want to do is, ultimately, I want it to be like this, right? So, not too bad off. What's not similar? It looks like they're reciprocal in a sense, but not only that, what about our 1 minus cosine theta to what is it over here? Well, what do you think can help us get that? A conjugate. Good. So right there, so you can see I'm just kind of think out loud with you so you can have different thought processes to go with. So I'm thinking conjugate. Okay, so if I multiply by 1 plus the cosine of theta, then I multiply numerator and denominator by 1 plus cosine of theta. Okay, I'm going to go back and make some notes real quick. Okay, I put some notes up there. Alright, let's send our numerator. Oh, I'll do this in red. So let's do 1 times 1 is 1. 1 plus cosine of theta is just positive cosine of theta. Then I come back here. Negative cosine of theta times 1 is negative cosine of theta. And then a negative cosine times cosine will be cosine squared theta. Okay, now let's work with our denominator. Sine of theta, I can FOIL that out, or I can just leave that right now. I like that it has that 1 plus a cosine of theta because I have it up here. So let's just not FOIL that one out yet. Okay, if we decide to do that later, we can, but I like that this 1 plus cosine of theta is looking like this. So I'm just going to try to hold on that as long as possible. Now let's simplify the numerator. This cosine theta minus cosine theta is gone, and I'm left with 1 minus cosine squared theta. Well, what will that give us? 1 minus cosine squared theta. I'm just going to write the extra step so I can put a note by it. And what is this? Pythagorean. Okay, which that would give us sine squared theta. Good. Sine squared theta over sine of theta times 1 plus cosine of theta. Now let's keep in mind where we're going. We want it to be 1 sine of theta and just this on the bottom. Well, we like that, so what happens here? Just simplify, right? Divide a sine of theta out of each of those, and we will have, get a little more, we will get sine of theta over 1 plus cosine of theta. And that's what we were looking for. So a lot of this is knowing where you're going and trying to use the tools that help you get there. Alright, we have cosine of theta over 1 minus sine of theta equals 1 plus sine of theta over cosine of theta. And we want to, let's work with our left hand side and try to make it match this. Now, if I bring my left hand side down, because that's the one I'm choosing to work with, I want to think, first of all, it's already in terms of sine and cosine. It's already as one term, so one term. I'm thinking if I compare it to here, one thing's going on. It's looking like a reciprocal's happened. Not only that, what about 1 minus sine of theta, 1 plus sine of theta? When we see that happen, that's our key indicator that we're going to multiply by 1 plus sine of theta here and 1 plus sine of theta. So multiply by the factor of 1 plus sine of theta to the numerator and the denominator. Now, right here I could distribute this out, but what about it in my numerator? I like that it looks like this already. So because I like that it's staying there, I want to try to keep it in that format. So I'm just going to bring it over and say, well, cosine of theta, 1 plus sine of theta. And I'm not going to FOIL that out, so to say. I'm not going to distribute it out just yet. But the denominator, I am. So let's FOIL this out because it's a single term. So clearly something's going to simplify if I FOIL this out. So 1 times 1 is 1. And you should be familiar with this now. So plus sine of theta. Then this term, negative sine of theta times 1 minus sine of theta. When we use conjugates, that middle term cancels out, the middle two terms. And a negative times a positive is a negative sine squared theta. Okay, those cancel, so I'm just going to leave my numerator alone. And then in my denominator, I'll have 1 minus sine squared theta. And what do we know about that? That is our Pythagorean identity, which is what? Which one? 1 minus sine squared theta is equal to cosine squared theta. Good. And then our cosine theta out of each one of those, that would just leave us with 1 plus sine of theta over a cosine of theta, and that is exactly where we were trying to go. Okay, cotangent squared theta is equal to cosecant theta minus sine of theta over sine of theta. So I want you to try this one. We're going to pause it, just let you attempt it, and then we'll check your answer. Like I said, sometimes there's more than one way to do it, so as long as you are able to establish the identity using all of your identities and the techniques, then that's okay. But I am going to suggest that we work with our right hand side. You can see it's definitely a lot more complicated, so let's just try. I'm going to work with the right hand side this time just to give you a heads up. Okay, so the first thing I did is I rewrote this in terms of sine. So this I rewrote as 1 over the sine of theta. Just carried this one over, but I put it over 1 so that I could see that both of those were fractions. Just my denominator, I just carried it down. The next thing I did is I got a common denominator in the numerator, which would have been a sine of theta. So this is already over sine of theta, so I just bring down the 1. This needs to be multiplied by sine of theta, so does this, would give me sine squared theta. This numerator gives me, using Pythagorean identities, is going to simplify to cosine squared theta. And I just bring this down, and it's over the entire denominator of sine of theta. Now this next part, I'm just simplifying algebraically. I don't want a fraction divided by a fraction within a fraction, so I'm going to simplify this by multiplying by the reciprocal. Whatever you do in the denominator, do in the numerator as well. Cosine squared theta, sine squared theta, and of course everything down here is going to just simplify out. So cosine squared theta over sine squared theta is cotangent squared theta, and that's where we're trying to go. So I use this example to show you that we do have the option of working with the right side and making it match the left side. It just depends on which one you feel like is the easier approach. I like to work with the more complicated side more times than not.